Aloha and welcome to this module on coding standards. I really think this is one of the most important things that you will learn this semester in ICS software engineering. The importance of standards in general and coding standards in particular cannot be overstated. It's almost as if you don't use standards, it would be like you have a bunch of people and they're all speaking different languages and you can't understand each other, and any kind of communication is really difficult. So even though you may not agree either in this class or elsewhere with the standards that are enforced, I hope that you will come out of this experience recognizing that adhering to a standard, which is hopefully the standard that you think is best, but in any case some kind of standard is more important than everybody following their own idiosyncratic style, which they think is best, and creating systems that are this melange of stuff. And it is very much more difficult than it needs to be to evolve and understand and bring new people into. Okay, so in this module, we're going to talk about the motivation for coding standards briefly, just like I already did. And then I want to help you guys learn how to write code that conforms to the standards that we'll be using for the purpose of this class. I want to give you some experience looking at code that does not conform to the standard and recognizing places where there are violations, because that's always very important. And then finally, coming out of this, you're going to be very excited to use tools that help you discover when code does not satisfy the standards, because it's very difficult to see violations actually. I mean, you can see certain ones pretty easily, but having automated support for it is very nice. And we have a good tool called CheckStyle that can look for certain kinds of errors. For the very basic kind of layout stuff, you'll be able to import a Eclipse format style sheet or set of rules into your Eclipse environment, and then you can just do a little propeller shift F kind of thing, and it will automatically format in terms of braces and new lines and stuff your code to conform to the convention. So it's there is tool support to make this fairly easy. And then, the big question is kind of what are these standards? And not all standards are at this low level of just layout of code. There's higher ones as well. Okay, so adhering to coding standards is a key part of collaborative software engineering, team-based system development, because it so immensely improves readability. Okay, and the way it improves readability is that when you're looking at code, you're not tripping over someone else's idiosyncratic notions of where to put braces and how many spaces to indent and all that stuff. It's always going to look the same. So you can focus in on the actual logic and design of the code without being put off by these kind of structural idiosyncrasies, I guess. Okay, and then we can do checks to make sure that basic levels of documentation are always present, and it makes maintainability a lot better because you're not looking at code that looks like it was written by 14 different people, at least superficially. Okay, so what we're going to use as our basis for standards in this class is the Elements of Java Style. There you can see it. This is a great book. Okay, I really like this book. It was written a number of years ago. Very well written. Look how small it is. Okay, very small. It's just about, it's less than 100 pages, and each page has, just a couple paragraphs on it. So you should be able to whip through this book in, I don't know, an hour, 90 minutes. What I recommend, it's coming up to Labor Day weekend. You're going out to the beach, you're hanging out with your family. Just tuck this puppy into your pocket. Take it with you to your family gathering, the barbecue at Magic Island, whatever. While everybody else is chilling out, you just hang out with the Elements of Java Style. You can read it really pretty quickly. Okay? Plus, it's actually really well written and kind of interesting. You'll learn about lots of best practices for Java development that you might not have known about before. And it's very easily digestible. teaches you not, it teaches you about documentation, best practices. It teaches you how to name classes, variables, and so forth in an elegant way. It teaches you some interesting kinds of coding level issues as well. So it even gets a little bit into the design stuff. Okay, so this is not it was a required book for the class. Hopefully you all have a copy, and I really want before Tuesday for the next class period for you to have gone through this book and read it. Okay? Read it at least once. You might even end up reading it a couple times. But in class on Tuesday, we're going to do an exercise which requires you to be familiar with the contents of this book. So I really want to see you doing it. Okay? All right, so it's divided into a bunch of different sections: general principles, formatting, naming, documentation, and so forth. And what I'm going to do now is like a little whirlwind 10-minute overview of the book, highlighting various things, but I'm not going to go into any detail. And the great thing about this book is not only that it gives you a standard, like capitalize the first letter of each word that appears in a class or interface name, but it also explains why that standard is interesting and shows you examples that conform to it and examples that don't. So the explanations are really key. Okay, don't just look at the actual guideline, but read the explanation as well. Okay, so there's some general principles, which are kind of just general principles for development in general. That's why they're called general principles. I like the principle of least astonishment, which means you want things to be simple, clear, complete, and consistent. Okay. Try to do things right the first time, and that kind of refers to not going and writing the whole system and then adding comments, not writing the whole system and then adding tests. Try to create your system in kind of incremental layers, like an onion kind of thing, starting very small, but well documented, well tested, reliable, et cetera, and then you kind of grow out from there, but you're keeping it kind of releasable along the whole way. Okay, formatting conventions. For this class, it's going to be 2-space indentation. Again, I'm just going to say even though that's my idiosyncratic, I believe it's better, but there's lots of people who can argue that 4-space indentation is better. We're not going to have kind of, religious wars. Okay, it's just this will be the standard for the following 4 months. And when you get out, if you can convince your organization that you're working in that 4 spaces is better for your software, by all means, go ahead and do it. It just should be consistent, right? We don't want to have some 2-space, some 4-space. And again, the Eclipse formatter will enforce this or automatically format your code this way if you set it up that way. 100 characters per line maximum. Have some white space. Do not use tabs. Tabs are the spawn of the devil. And in Eclipse, there's a setting which will automatically remove tabs and replace them by spaces. Naming conventions, okay? In general, the name should be meaningful. Do not use one-character names. Use names that make sense for the application domain. A nice little heuristic, if you have some really long variable name, maybe that means that your design is a little suspect. You might want to rethink it. If you're a C programmer, in Java, the convention is to actually use vowels. Okay, so you can have them in there. There's a convention that if you have acronyms like XML, which are normally all of them are capitalized, the convention is you only capitalize the first letter, so X is capitalized, ML is lowercase. Even the Sun people who are responsible for many of these guidelines here, even they don't get that right all the time, so it's a little frustrating, but that's the guideline. The important one is that you don't want to have names that differ only in case. So for example, the instance with a lowercase t could be a variable name. The instance with a capital T could be a class name. You don't want to have a class name and a variable name that are exactly the same and differ only in case. It's just a source of potential problems. For packages, use reverse internet domain names. Try to use single words for each package. If you have something like server kernel file system, it's probably not a good package name. It probably also means maybe you're grouping together a number of things that should actually be in separate packages into one package. In a class, you want to capitalize the first letter of each word, including the first word. When you're naming a class, it should be a noun. Okay, that's kind of building off the general object-oriented design tradition. If you have a class that groups together related attributes, then pluralize it. Interfaces should be nouns or adjectives depending on what you're doing. Method name should have a lowercase first letter, and then the remaining words are all uppercase, so get server hostname is an example of that. When you're naming methods, you probably want to use a verb. When you're creating accessor methods like get, set, or booleans, you use is, get, and set. That's the Java Bean conventions. Variable names, you lowercase the first word, uppercase the remaining one, so daytime is one word in this particular instance. Okay, for names, we want to use nouns for variables. When we have collections, we want to pluralize them. So you can see here's an array of customers, so that would be pluralized. And then, even though I said in a previous slide that you'd want to avoid, one character variable names, there are certain exceptions to that rule. So if you're using an index in some kind of for loop situation, use I, J, and K. Those are the standards. When you're catching exceptions, it's fine to use the single letter E to indicate the exception that's being caught. And then if you're defining generic types, you use the standard type variables capital S, capital T. Okay, so those are the only situations where not only are single character variable names preferred, but if you don't use them, actually it's a violation of the coding standard. Okay, when you're referring to field variables as opposed to parameters to a method, you